Welcome back, friends, to this brand new Techhandy course on VMware vSphere 7. If you're interested in VMware virtualization, you're in the right place. In today's video, we're moving deeper into the networking portion of vSphere, and we're going to explore one of the most powerful and essential features in enterprise VMware environments, the vSphere distributed switch, also known as VDS. In this session, we'll first understand what a distributed switch is, why organizations use it, and how it differs from a vSphere standard switch. Then we'll walk through a complete hands-on demonstration where we create a distributed switch, configure uplinks, build dvPort groups, migrate VMkernel adapters, and finally migrate virtual machines to the VDS. A vSphere distributed switch is a centrally managed virtual switch that spans across multiple ESXi hosts. Unlike a standard switch, which exists and is configured individually on each host, a distributed switch is managed entirely through vCenter, and all connected hosts use the same switch configuration. This ensures consistency, reduces manual network configuration, and provides advanced enterprise-level networking features. Before we move further, it's important to understand the core components of a distributed switch. We have the management virtual adapter, which handles host-level management traffic. The server dvPort group, which is used for virtual machine networking. The vMotion dvPort group, responsible for live migration operations, and the storage virtual adapter that carries ESXi or NFS storage traffic. You will also see production DV switches used for actual application workloads and storage DV switches used to isolate storage performance. Alongside these components, we have uplink adapters, which connect the distributed switch to the physical network and provide redundancy and load balancing. All these components work together to form the physical and virtual networking fabric of a vSphere environment. Understanding the VDS architecture means understanding both the physical and virtual network paths. On the physical side, uplinks from ESXi hosts connect to top-of-rack switches. On the virtual side, distributed port groups define how traffic is organized and controlled. Each distributed port group can carry a specific type of traffic management, vMotion, FT logging or fault tolerance logging, vSAN, storage, production workloads, or DMZ workloads, each with its own policies and traffic shaping settings. Because of this centralized model, traffic flows are predictable, easier to troubleshoot, and far more scalable. A vSphere distributed switch becomes the preferred choice when your environment grows beyond a few standalone hosts and consistency is key. If you're working with multiple ESXi hosts and you need all of them to follow the exact same network configuration, a VDS is the most efficient way to manage that. It eliminates the need to configure each host manually and ensures every setting is synchronized across the cluster. VDS is also essential in environments running vMotion, DRS, high availability, vSAN, or fault tolerance. These technologies rely heavily on reliable and uniform network paths, and a distributed switch guarantees stability and consistency across all hosts participating in these services. Many organizations choose VDS because it supports advanced networking features that simply aren't available on a standard switch. Features like LACP for link aggregation, NetFlow for deep traffic analysis, private VLANs for segmentation, and network I/O control for prioritizing critical workloads, all of these require a distributed switch. In enterprises where centralized management or compliance controls are critical, a VDS becomes even more important. It provides a single point to manage, audit, and enforce network configuration, reducing operational risk and ensuring that changes are applied consistently. Large-scale applications that span multiple hosts also benefit from a unified uplink design. A distributed switch helps maintain consistent performance and eliminates the complexity of managing individual host switches. And generally, once an environment grows beyond 3 hosts, the time required to manually configure each vSphere standard switch becomes significant, making a distributed switch the smarter option. When comparing a vSphere standard switch, or VSS, to a vSphere distributed switch, the difference really comes down to scale and capabilities. A VSS vSphere standard switch is configured individually on each ESXi host. It's lightweight, simple, and ideal for labs, standalone servers, or small environments where advanced networking features are not required. There's no centralized interface, meaning the administrator has to manually configure every host one by one, and only basic networking functionality is available. A VDS, on the other hand, brings centralized management to the entire environment. Instead of configuring each ESXi host separately, you create and manage the switch from vCenter, and all connected hosts automatically inherit the configuration. This makes management easier, reduces human error, and ensures full consistency across the cluster. A distributed switch also comes with enterprise-grade features that a standard switch simply doesn't offer. These advanced capabilities make VDS the required choice for any environment using modern vSphere features like vMotion, HA high availability, DRS distributed resource scheduler, or vSAN. So in summary, a VSS is simple and host local, while a VDS is powerful, centralized, and designed for scalable, enterprise-level environments. Enough theory, now let's jump into the demonstration and perform the full configuration step by step. We have 3 hosts in our cluster, each with 2 physical network adapters connected to the network. To create a distributed virtual switch, we're going to network inventory where we have by default VM network, of which all the physical hosts are using through their standard virtual switch. To create a new distributed switch, right-click the data center and select Distributed Switch, then click on New Distributed Switch. In our case, we will name our first distributed switch as Production. The distributed switch version determines which vSphere features and capabilities are supported by that switch. You select a version during creation to ensure compatibility with your existing ESXi hosts and vCenter, based on their supported feature sets. In our case, all our ESXi are 7.0.3, so we'll go with same. We will discuss configure uplinks and port groups later, for now just going with default and uncheck the box of creating default port group. Our production distributed switch is now created. We will create one more distributed switch in similar way and name it as storage. To delete a vSphere distributed switch, ensure no hosts or port groups are attached to it. Right-click on distributed switch you want to delete and then select Delete. We are not going to delete since we will need to configure these distributed switches further. At this point, the only thing we're doing is adding 3 hosts to the production distributed virtual switch. We'll configure rest configurations in next topics. Right-click the distributed switch and click on Add and Manage Hosts. Then click on Add Hosts. Add hosts that you would like to be part of production cluster. In our case, that will be Node 02, Node 03, and Node 04 since they are the part of same cluster. Next step, we being asked to manage the physical adapters. This distributed virtual switch is a virtual switch, and for that virtual switch to gain access to the physical network, it's going to have some sort of physical adapters on each of your ESXi hosts. At this point, if there are uplinks that we want to assign, we can select the uplink and click Assign Uplink, but we will configure that later. The next thing we're prompted to do is to manage VMkernel adapters. On each of these 3 hosts, we have a single VMK0 or VMkernel adapter, which is currently part of vSwitch 0, and it's on the management network port group. We also have the option to migrate these VMkernel adapters and any existing virtual machines, but this also we will configure under later topic. Our hosts are now added under production distributed switch. We will repeat the same steps for our storage distributed switch. Removing hosts from distributed switch is also easy. Right-click on distributed switch and select Add and Manage Hosts, then select Remove Hosts. Select the individual or multiple hosts that needs to be removed from this distributed switch and confirm to remove. dvPort groups are kind of organizational units on a distributed switch that your virtual machines are going to connect to. dvPort group defines a consistent network configuration, VLAN, security, traffic shaping, for all VMs connected through a vSphere distributed switch. It centralizes network settings so multiple ESXi hosts apply the same configuration automatically. To add a new distributed virtual port group, right-click on distributed switch, then select distributed port group and click on new distributed port group. Give a meaningful name for the purpose this port group will be used for. In my case, I will name it as Server Distributed Port Group. For now, we will go with default configurations and will explain these configurations items later part of this video. Our server dvPort group is now created. This is where our virtual machines will be connecting. You will now able to see port group under available networks of existed virtual machines, but we are not going to migrate the virtual machines network connectivity at this point because we don't have any uplink adapters connected yet to the distributed switch, so if we move this machine, it will not be able to communicate with the outside network. You can right-click on port group and can edit settings, rename and even can delete port group as well if needed. But before you delete, you must disconnect or migrate all VMs and VMkernel adapters from the port group, else you will not able to delete it. In vSphere, uplink adapters are grouped in what they call uplink groups. So if you remember when we created our new distributed virtual switches, it asked us how many uplinks would we like in the uplink group, and we had selected default 2 uplink per host. Now we need to add uplink adapters to those slots. We currently have 6 uplinks ports, 0 through 5 available to us to add physical adapter to. Which is same for both production and storage, which are actually 2 on each of our 3 ESXi hosts. So 2 times 3 is equal to 6. To add a physical adapter to the uplink group, right-click to the distributed switch and select Add and Manage Hosts. Then select Manage Host Networking. Select the hosts to assign uplinks. Now we need to select which physical network adapters, which VMware calls VNICs, we want to migrate to our new distributed virtual switches. We are doing it on VNIC 1 on each of the 3 hosts. Select VMNIC1 and then select uplink 1 to assign this to all hosts under VMNIC1. We are not making any changes to VMkernel adapters or migrate VM networking at this point. We will now able to see uplink adapters assigned to uplink 1 from each of the 3 hosts that are part of this distributed virtual switch. Let's explore what the VDS and the dvPort group settings can offer you as an administrator. What are the types of things that you might want to configure to provide additional performance, additional security, or management functionality? Under following path you can find the main settings and subsettings, such as private VLANs and the NetFlow configuration. You can export the configuration of one distributed virtual switch, and then restore that configuration later. Under main settings, you can reconfigure or rename the distributed virtual switch, can enable disable I/O control for the entire distributed virtual switch. Recommend is to leave it enabled, because network I/O control is a greater feature that ensure that critical applications receive the bandwidth from the distributed virtual switch that they need to ensure those applications run well, and especially critical vSphere services. Under advanced settings, uplink MTU defines the maximum packet size that can pass through the physical NIC connected to the VDS. It must match the MTU on the physical switch to avoid fragmentation or dropped packets. Multicast filtering mode controls how multicast traffic is handled on the VDS. It allows you to choose between basic or IGMP/MLD snooping for more efficient multicast traffic management. Under Discovery Protocols, CDP or Cisco Discovery Protocol, and LLDP, Link Layer Discovery Protocol, allow ESXi hosts to discover and advertise information with physical switches. CDP is Cisco proprietary, while LLDP is industry standard and vendor neutral. Operation and administrator contact settings allow the VDS to advertise operational status and admin contact details, name, phone, email, to neighboring physical switches. This helps physical network admins quickly identify and manage VMware-connected switch ports. You can think of uplinks as uplink slots per host that will be part of the distributed virtual switch. You can add the number of uplinks, and same time can remove the uplinks easily. You can also update the uplink name if required. There are some additional uplink settings that you can go in and review under topology. Can change the view to data grid if wish to explore further. Same way you can further explore the port group settings. You can rename the dvPort group. Under port binding, default is a static port bindings, with the alternative being an ephemeral port binding, which means no binding at all. So with static, when a virtual machine connects to a distributed port group, it's assigned a port. However, with ephemeral, there's really no port being used at all. Some say this is a benefit actually, so that virtual machines can be powered on even if vCenter is down, because vCenter is required for a static port binding when a new virtual machine is powered on. However, others say that ephemeral is a less secure option. Recommendation is to take the static binding option, unless you have some reason not to. If you do choose a static binding option, you can choose the port allocation method, which is either elastic or fixed. With the elastic option, port groups automatically increase or decrease as the ports are consumed, and that would be recommendation. Whereas if this set to fixed, We will have a maximum of 8 virtual machines or number we listed that can connect it to this dvPort group. You can also configure the network resource pool. When a virtual machine disconnects from the dvPort, do you want any per-port overrides to be thrown away? You can set default enables for, configure reset at disconnect, otherwise you can disable it. Further, you can also configure override port policies. There are some more features available such as VLAN, security, traffic shaping, teaming and failover, monitoring etc. that we'll try cover in next coming videos. Share your comments if you would like to see more videos on these topics. Now we are going to create new VMkernel adapter that will be used for storage traffic. Talking about ESXi, NFS, and VMware vSAN. That VMkernel adapter will connect to the new storage DV switch, and we'll need to create a port group in order to make that happen. Follow same steps as we performed earlier to create the server distributed port group under the production distributed switch. We will name this storage dport group. Later we need to migrate our existing VMkernel adapter that's on the standard switch to the production distributed virtual switch. We'll also need a management port group. Let's create that as well with defaults and named it as management dport group. Let's go over to the host and cluster inventory, and on our 3 nodes that'll be part of production cluster, we want to go in each one and click Add Networking, and add a new VMkernel adapter. Under Existing Network, select Storage dport group that we just created. We don't have to select any network services here to use this for ESXi and NFS, as long as the ESXi and NFS arrays are on the same IP subnet. Since we won't be connecting inbound traffic to this VMkernel adapter for management, it's not required to have a static IP address, but in production environment, it would be recommended. Our new VMK1, or VMkernel 1, virtual adapter has been created, connected to the storage dport group, and it doesn't have an IP address. But why VMkernel adapter is not getting an IP address via DHCP? There are 0 network interface cards connecting this distributed switch to the physical network, and that's the reason why the VMkernel adapter doesn't receive an IP address via DHCP. Let's perform same above steps on all remaining hosts to add VMK1 VMkernel adapters first. Now let's attach physical network to interface cards on all hosts to assign IPs. This time we will assign uplink 1 to available physical VM NIC 2 on all hosts. VMK1 already attached to storage dport groups. If we take a look at each of our vMkernel adapters, notice now that our new vMkernel adapters has an IP address on this subnet. And it's the same for other nodes. There is also an easy way to make it done. Instead of going one by one and adding vMkernel adapters to each host, we can go in here and quickly add new vMkernel adapters to each of the hosts. As you can see before, we have 3 vMkernel adapters here, now we have 6. We can also see there's the new vMkernel adapter, VMK2, that we just added to each of these 3 hosts simply with a few clicks. You can also easily remove that vMkernel adapters. In this part of video, we will figure out how we migrate virtual adapters to a distributed virtual switch that are already created. We have 3 nodes, and each one of these has both the new vMkernel 1 that we created, that was already connected to the distributed virtual switch, as well as the original vMkernel port, VMK0, that's still connected to the vSphere standard switch. We need to migrate vMkernel adapter VMK0 on each of the 3 hosts to vSwitch 0. We need to migrate this vMkernel interface up to the distributed switch name production, and there will be a management port group or distributed virtual port group. To migrate VMK0, we will right-click on Production Distributed Switch or where you want to migrate and then select Add and Manage Hosts. Then go with Manage Host Networking. In our case, we will select all the 3 hosts. Under vMkernel adapters, select the VMK0 and assign Management dport group that we created recently to migrate virtual adapter from existing standard switch. As you can see, port group is now changed to management port group. We can also see VMK0 is now migrated from standard switch to our production distributed switch under management dport group and no further exist under standard switch. And that's the case for all the 3 hosts under our production cluster. At this stage, you can safely remove the standard switch vSwitch 0 from all 3 hosts or can keep it for future use case. Now, finally, it's the time to migrate the virtual machine to distributed switch. Thankfully, VMware makes this easy. Select Add and Manage Hosts under your distributed switch where you want to migrate the VMs. No change this time to the physical adapters and vMkernel adapters. Under Migrate VM Networking, select the Migrate Virtual Machine Networking checkbox. That will display the network adapter settings and option to assign new port group where you want to migrate the machines. If you wish to migrate multiple machines, this could be helpful. Simply assign the new port group and machines will move to this new port group, or you can configure per virtual machines for selected VMs only. As you can see, our Server 2016 machine is no longer exist under standard default VM network. You must ensure the same VLANs, port groups, and uplinks exist on the distributed switch before migrating VMs from the standard switch. For single machine, as we seen earlier under settings, you can change network manually as well. You can also do the same simply through port group as well. Simply select the port group where you want to migrate the VM and select Migrate VM to another network. And that completes our full deep dive on vSphere distributed switches. We covered what a VDS is, why you'd use it, the key differences from a standard switch, and completed all major configuration tasks, from creating the switch to migrating VMkernel and virtual machine networking. In the next video, we're moving into the storage section of vSphere. We'll cover the different storage types, data store creation, and how storage integrates with clusters and virtual machines. If you found this video helpful, please leave your feedback, like the video, subscribe to the channel, and let me know what you want to see next.